Today, we're going to talk about a piece of tech that is completely changing the game when it comes to finding things. Turning our search bars from these rigid, kind of dumb dictionaries into a partner that actually gets what we're trying to say. Let's dive in.
You know that feeling, right? You've got this complex idea, this concept in your head, and you have to play this frustrating guessing game, trying to figure out the exact magic words the machine will understand. It's a feeling we've all had, and it turns out there's actually a name for it.
Okay, look at this. This slide just lays it out perfectly. On the left, you've got your standard keyword search. It's totally literal. You type canine, you get canine. That's it. But on the right, that's vector search. It understands that canine is an idea, and it goes and finds other things that are conceptually related, like dog, puppy, or even wolf. It's the huge difference between just matching words and actually understanding meaning.
And that frustration has a name. It's called the semantic gap. It's why we've always had to, dumb down our brilliant, nuanced thoughts into these clunky little keywords. For decades, we've been the ones doing all the hard work, basically translating for the machine. Well, that's finally starting to change. So to really appreciate just how big a deal this new solution is, we had to first understand the old enemy, right? Keyword search. What's really going on under the hood, and why does it fail us so often? The whole thing boils down to this. It's all about lexical search, which is just a fancy way of saying exact word matching. The algorithms it uses are basically just really fast word counters. They have absolutely no idea that a puppy is a young dog or that a word like freedom can mean totally different things depending on the context. The entire burden is on you, the user, to guess the right combination of keywords.
And this table just drives the point home. We are moving from a world of exact word matches to one of semantic similarity, of finding things that have a similar meaning. Your job is no longer to downgrade your complex question into a few keywords. Now you can just ask your question using natural human language. We're finally making the machine learn to speak our language, and not the other way around.
Okay, so that's the problem. Let's get to the good stuff. The hero of our story, vector search. This is all about searching by what you mean, not just the words you type.
And this is more than just a slightly better search bar. It's a completely different way of interacting with information. Think about it. Keyword search is about filtering. It helps you find a document when you already know a specific word is in it. But vector search, that's about exploration. It's for discovering connections and ideas you didn't even know existed.
So the query itself, the way you ask, totally changes. It stops being a rigid command and becomes more of a creative prompt. You can now ask the machine to find things that just feel like your idea, things that share its conceptual DNA. For anyone doing research, for any creator looking for inspiration in a mountain of data, this is an absolute game changer.
Okay, so this sounds like magic, but how does it actually work? Let's break down the mechanics, and don't worry, we're going to stick to simple analogies here. It all comes down to turning words into coordinates on a map.
It's really like a three-step dance. First, a special AI model goes through everything, every word, every document, every image, and gives it a unique address or a coordinate on this enormous map of meaning. Things that mean similar things, like king and queen, get plotted really close to each other. Step 2, your search query, it gets its own coordinate on that very same map. Then the database just has to find its closest neighbors, and, this is the clever part, to do that across billions of items in a split second, it uses a trick called approximate nearest neighbor, or ANN, to find the almost perfect matches instantly.
Now, I know what you're thinking. The word approximate sounds like a bug, not a feature, but it's actually the secret sauce. It's this brilliant trade-off. See, you don't always need the one and only 100% perfect answer. What you need are the 99% perfect answers, and you need them right now. That's what makes this a real usable tool.
All right, so that's the theory. But what does this actually mean for people who work with massive amounts of information for a living? Like researchers in the humanities and social sciences. This is where things get really interesting.
So imagine you're a historian. You want to track how the meaning of a big concept, say democracy, has evolved. With vector search, you can literally compare its closest conceptual neighbors from different time periods. In newspaper articles from the 1960s, democracy might be clustered near words about the Cold War, like anti-communism. But fast forward to the 2020s, and it's much closer to ideas like citizen participation and diversity. You can now literally measure and prove how a core idea has shifted.
Or let's say you're a sociologist studying online discussions.
You could take thousands of comments about one topic, turn them all into vectors, and see how they cluster together on that map of meaning. You might find two totally separate groups talking past each other, using completely different language and concepts. You can visually see echo chambers forming, and even measure the semantic distance between them. It's an incredibly powerful way to map public opinion.
But listen, this is not just for academics. This is a legitimate superpower for any professional. Lawyers, consultants, writers, creators, anyone who has their own massive, messy archive of knowledge.
For a small law firm, picture this. Instead of trying to guess complex legal search terms, you just type in your client's story in plain English. You search for precedents for a leaky ceiling causing mold, and bam, the system instantly finds conceptually similar cases, even if they use totally different legal jargon. This could uncover connections you would have completely missed otherwise.
And if you're a consultant or a writer, think about it. All your past work is your biggest asset, but it's probably scattered everywhere. Vector databases let you turn that entire chaotic archive into your own personal searchable knowledge base. You can literally ask your own data questions like, what were my best arguments for this kind of project? It's like having an assistant who has perfectly memorized every single thing you've ever written.
And for all the creators out there, this gets even cooler. This tech isn't just for text. It can understand images, audio, and video too. So you can finally search your 10 terabytes of footage, not by some meaningless file name like A001C02, but by the feeling. You can ask for a quiet and lonely morning city vibe or a hopeful sunrise and get the perfect clips in seconds. You're searching by mood, which is how creatives actually think.
Okay, so let's zoom all the way out, because this technology isn't just a better way to search. It's actually a fundamental building block for the entire future of artificial intelligence.
We've all seen the big problems with tools like ChatGPT, right? Their knowledge is stuck in the past, and worse, sometimes they just confidently make stuff up, what we call hallucinations. Well, vector databases are the key to fixing this.
The technique is called Retrieval-Augmented Generation, or RAG for short, and it's actually pretty simple. Before the AI even tries to answer your question, it first does a super fast vector search on a database of trusted, up-to-date information. It grabs the relevant facts, adds them to your original prompt, and then gives the AI one critical instruction. Answer this question, but you can only use the facts I just gave you. This one step grounds the AI in reality.
So if you remember one thing, make it this. Vector databases are becoming the long-term memory for AI. They give AI a reliable, up-to-date source of truth. They solve its biggest flaws and are turning it into a tool that's genuinely useful for serious, professional work.
And really, that brings us to the final question, the one for you to think about. This technology turns any archive, your old research notes, your company's documents, your personal photo library, into a searchable map of meaning. So the real question is, what hidden connections and forgotten ideas are just sitting there, waiting to be discovered in your data?